Okay, so this is for Friday. This is for Friday, the 18th of September. I'm going to do these Friday wrap-ups on Saturday because Friday, I have a life, so I don't necessarily get to it Friday night. But Saturday by noon, I should be able to have it up. All right, so I'm going to share the screen. Let me pause it here for a second. So this is for class number 12. All right, so I wanted to point this out. The main thing we went over on Friday was this. Oh, sorry, I'm on the wrong thing. Okay, so this, yeah. So here's a note to it. Oh, okay. So what I'm showing you here is 1.5. That's what confused me, is that lead up there. But this is 1.5. This is from the Facebook group. So there it is. I put the sheet on all the new sheets also on Canvas, but I put them in the Facebook group under Unit 1. So it's easier there for you to find them, and then also to find the keys eventually, but also to find help. So this is up from the Facebook group, and the first comment is a silent help video, which shows you how to work number 1 in the sample problem. And I had a student work it that was watching it at lunch, and she said it really helped. So you ought to try it. They're not long. Sorry. So that's on the Facebook group. Join us. We got about 70 people, 70 students out of 83 are on there. So you should join. This is on the Facebook group. It's on the Canvas as well. It's on Canvas under Module 3. It's the PDF of the test, of the take-home test. If you want to start on that this weekend. It's not due until Friday next week. Now the main thing you want to look at here is read over all of this up here. Okay, read that over. It's right on there in the test. So that's kind of how we're going to do it. I've been thinking about it for a week or so, off and on, and that is what I've come up with. So if you can't print it off, I will print off some today. I'll go to the high school and print off some. And then you can come by my home. If you don't have a printer, I'll put 20 or so into a box, and then you can come by my house, 812 Carriage Lane, pick them up. So you have all week to do this, and I know we'll be virtual this week, but I'll be available, and there'll be a lot. We'll really be relying, I think, on the Facebook this week. Yes, Canvas some, but it's not near as user friendly. Okay, here's the back side. So you can see it covers this take home will cover sheet 1. It'll cover sheet 1.1 through 1.5. The only thing from 1.5 is this last one. The rest of it's all from 1.1 to 1.4. All right. So it's free response. This is not like a quiz. I mean, there are some multiple choice questions up here, but we're not. I'm going to try and figure out how I want you to submit that. You're going to submit it through Canvas, but I think I'll just put a kind of a shell in there, and then that's where you'll put your pages, or that's where you'll address them to. When you take a picture of your PDF or do a PDF. Anyway, that's Friday next week. So here's what happened yesterday. We started off. We went to the laptop, and I showed them kind of some of the good things about the Facebook group. Now there's group 1 now is the sheets and their keys and our comments, our discussions about those sheets and keys. And unit 2 is the take-home test. So that's where we're going to, and I'm going to make it, I'm going to put every problem as a separate post so that we can talk about each or every set of problems. Like I'm not going to put every metric problem on there, but I'll put the metric section, and then we'll talk about that. Or it'll be something on unit analysis. We'll talk about that. But below the picture, you have an area for discussion. So I'll put that up. Right now the test is up there, and I'll break it up into problems sometime today, probably. And that'll be up there as well. Certainly up there by tomorrow. I also want to show you that here is the key. It's been redacted, censored for now, but here's the key to sheet 1.4. Kind of just so you know the format I'm looking for. And then for the ones that were graphs, you turn them into lines. That's the format I'm looking for. So that key, now this is due Sunday. So this here is due Sunday. It's on your to-do list, I guess, at 11:59. Okay, so p.m. All right. So we spent the majority of the day working on hold on. Working on gold standard unit analysis. We didn't do the sample problem because that is where the take-home test. I'm sorry, losing it here. That is where the help video is. So the help video is about this problem. So I don't want to keep repeating myself. We've already spent enough time putting together that help video. Okay, so we worked on number 1 together in class, and then we worked on. They went to the board and worked on number 2. So I'm not. This isn't going to be a full-fledged help video, but I'll pause this and kind of set up number 1 so I can, instead of just showing you the whole thing, but I can kind of walk you through it a little bit. Okay, let me pause this. All right, so this is number 1 that we did. We spent most of the time in class going over this one because I slowly went over it with them. So I'm not going to spend that much time on it, but I am going to kind of walk you through there's 10 steps. We went through each step. Well, I'll kind of quickly go through the main ones. So the first step is you circle all the numbers or the things that represent numbers, could represent time. You circle all those in the problem. Okay? Trying to organize yourself. The next thing you do is you label what each one of those things are. Well, like 513,000 miles an hour. I mean, obviously that's velocity. And then I had the kids in class tell me what they thought it was. Gigameters, that's something we said, well, that I had to cue them in. That's delta S. That would be how far we're trying to go, or how far the sun is going to go in that. Okay, how many gigameters will it go during the month of October? So October is our time. Okay, so then we come down here. Oh, and by the way, I highlighted the constants there. If I give you conversions like that, then you're going to use those. Now, when you take AP Physics, they may give you conversions. I used to do this sometimes because the AP test does it. You give them conversions they're not going to need. And then they had to pick out the conversions that they want. But here, being just learning this stuff, I'm not going to also put you through that. So any kind of conversion that is written there, you will use. If you didn't use it, if you look up and you didn't use one of those, you messed up. Okay, so those are I know 2 conversions we're going to need. So now we go through this, and okay, erase this. All right, so we have to do a little drawing. Now, when it's a drawing, it doesn't have to be a fancy drawing. Like here is here's the center of the Milky Way. Here is the Earth. Here's the sun. So that's it. The sun's going around the center of the Milky Way. All right. So then you come over here and I'm trying to rush a little bit through this, but And then you write out whatever symbol thoughts there are. Well, that's no big deal right now because we only really have one equation we keep using variations of. So that's yeah. So that's the equation we're going to use. It's just the red equation. Now I'm going to use the modification on it to say that we're not talking about delta x here. We're talking about delta s. Okay. Then we got to go over and isolate the variable, but it's already isolated for us. So in this isolating the variable, it's just the same equation. Now I changed that delta x, which I had written there. I wasn't, when I wrote that 3 or 4 years ago, I wasn't thinking that. So I made it delta s because delta s is better because it's not, the sun does not travel in a straight line. Remember that s is a combination of x, y, and z. So s is when you got curvy things. What I guess in geometry you might call arcs. Okay, so but curvy things is the technical version, is the technical term for arcs. All right. All right, so now in these boxes, it says you only, this is kind of overlooked by students because they screw this up all the time, but it says here you put coefficients and symbols of givens into these boxes. So you're not putting the actual numbers of the givens, you're putting the symbols. So this would be a, oh boy, did I just mess up? No, I didn't. All right, so this would be a V and this would be the T, right? And then now we're ready to start putting numbers in. So let's go ahead and put our givens in. And by the way, I have in the last 3 years started moving this. So once we get all our givens done, it becomes a squiggly line. I want to put a fence between the givens and the conversions. So once all the givens are submitted, then you put a fence up. Then it's like convert, 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 convert until you get to the end. All right, getting ahead of myself though. So in the givens, we have our velocity, and we just write that out of there. Oh shoot, I just realized, okay. I'm showing you the finished product, and it already has some kill colors on it. These are, like I said, these are our givens. Givens here, okay? So don't, try and ignore the green kill switch. This is like I said, this is the whole worked out problem. All I'm doing is I'm erasing it bit by bit so you can see it. So I couldn't really erase those green, the kill switches there. All right, so we're trying to end up in gigameters. So if I go over here to this side, you always want to put where you're trying to end up. So I'm trying to end up in gigameters. Okay, so you add that to the far right. So the game is to get from, and by the way, I have like 4 help videos on these kind of problems. So I'll add some more. But the game is to get from the left, to get from those givens all the way over to gigameters. And so we start to play the game, and the game is to do what I've already kind of shown you accidentally, is to kill all the units we don't want. So that's the green kill. All right, so let's go through and see kind of how we did it in class. We started with the givens, right? So it's a good idea to start with the givens. That green kill switch kills me. Okay, so that's a good idea. So we had 5280 feet in a mile, and then we did that to get rid of the miles. The next one up, we use the next thing that's in the, that's just a smart thing to do, because then you know you had to do those anyway, and that kind of, it's kind of like a puzzle here. Like you kind of get 2 free puzzle pieces as long as you put them in right. You know, you don't flip them. That's the only problem you could have. Here now that I'll add a, yeah, I guess I can do that. Yeah. Okay, I'm going to add a blue kill over the green kill. So we killed my, whoa, that's pretty thick. Let's change that a little bit. Okay, we killed Miles. because the greens, they're all killed except for gigameters. The next thing, we haven't killed October yet. We killed the feet. Okay, so the blue is like the running current total. The green is like the carnage that already happened. All right, so we keep going. Now we see that we need to get rid of, well, pretty much took care of the month. Looks like it's all that time from now on. So now we go through, and the next one we decide to go after is, oh, that's a good idea. Let's get the meters into gigameters. And here's another place where students make a mistake. These are the conversions, clever forms of one. That's all those conversions are. They're clever forms of one. All right, so the common mistake students make is, now there's 10 to the ninth meters in a gigameter, right? But when a student looks up on the ceiling up there at the conversions, they see the 10 to the 9 and they stick that 10 to the 9 with the gigameters. And that is a no-no. Well, it might be, but no, if it was in petameters or something, because you always put the big number with the small unit. I'm asking the question, how many meters are in a gigameter? Well, there's a billion. So that's kind of how you should say it. To make sure you get these, to make sure you don't end up switching these two numbers. That would make your answer off by 10 to the 18th, which, and you think, oh my gosh, I'd lose all the credit. No, that mistake, if it's a 20-point problem, only loses you 2 points. You only lose 2 points in that. So because it's made all the time, but you're right, it does make your answer off by trillions and trillions. Okay. Now let's go for, it looks like October. So we know there's 31 days in October. And someone said, well, what about, can I just do it? They called out the hours in October. Like they had already done it in the calculator. I said, wait a minute, nobody knows that. I mean, that's not common knowledge. So these need to be, all these clever forms of one need to be conversions that are given, that I've provided you, or other clever forms of one that you already know. Like I'm going to expect you to know there's 12 inches in a foot. There's some things that you just got to, there's 3 feet in a yard. Sometimes people do forget that one. So, I mean, I'll always try and provide it if you ask on a test, but some of those you're kind of expected to know. Because if you give them all the conversions up there, then it's just a matter of, it's like a puzzle. Sometimes you got to pull stuff, like you had to pull the days in October, out. You couldn't just, I'm not giving you that big of a hint, in other words. Okay, so now we keep going. Days, October, and then we know we have 24 hours in a day. But nobody knows how many hours in October off the top of their head. But we do know those two things. We know there's 31 days in October, and we know there's 24 hours in a day. So your two common knowledge then is what you got to use, because that's what you'd use in the streets, baby. When you're doing engineering out in the field, you need to be able to do these kind of conversions. And some things you should just have in your head. All right, well, so that's, at this point, you've gotten probably 19 out of 20, but you never give me the answer. So the answer, all you do there is, you just punch in your calculator. But I did go ahead and write the numbers out, because you got to punch. This is where a lot of students mess up. They get all the physics right, and then they screw up the arithmetic. That happens all the time in physics. So what I did here was I just took just to keep me honest and to kind of teaching this stuff, just so we can lay all the numbers out. So you punch all those in on your calculator. I would hit equals at that point, and then divide by the whatever's on bottom. So multiply all the top numbers, get a number. Multiply all the bottom numbers, get a number. Then, as a separate issue, divide top number by bottom number. I know I'm being extra careful, but that's the way over the years. This is how students make their mistakes, I'm telling you. This is what I observe. I grade tests constantly. This is how they make the mistakes. They don't multiply those numbers correctly because they're in a hurry. So a strong suggestion on a test is just to get it to this point, get it to this, not even the black, just get it to this point, right up here. Get, you can't see, okay, get it to this point, right to here, double slashes. And then once you've killed all the units you don't want and you kept the one you did, then you move on to the next problem. Now, if you have time at the end, because you're only losing 1 point. If you have time at the end, you come back and you punch it in. But it's stupid to spend a bunch of time punching in numbers into your calculator to get this one right. I know because you're a perfectionist and all. And then you sacrifice a 20-point problem at the end that you could have done in that same amount of time. You see what I'm saying? So it's just smart. It's a wise student that shows all the work. And then if the answer is easily gettable, then just waits on the calculations. They used to teach that method at Oklahoma School for Science and Math. And I used to teach that method too when I did the ACT stuff. But this is especially true for physics. Okay. Now that answer ends up being let's write down here. Ends up, well, I think I have it here. Yeah, there it is, 614 gigameters. So that means that you sitting in your chair in this classroom, if you just sat there for the entire month of October, you still would have traveled 614 gigameters. So somebody who's in isolation in a cell can take a little solace in that. If you have a 10 by 10 cement block cell and you're isolated and you're in solitary confinement, you think I can't go anywhere, but in reality you are going. You're orbiting the axis of rotation of the Earth. The Earth is going around the sun is going around the black hole. The Andromeda and Milky Way are coming together, but yet the whole thing is stretching out because of expansion of the universe. So all of that is happening to you in solitary. It's just you have no relative motion, but you still have a lot of motion. Okay, so something to think about. Now, that's it. So your homework then for this weekend is to do the take-home test 1A, and then, well, not do the whole thing. Just do, if you maybe just do the metrics or something. Do something. Get a problem or two under your belt. I'm a big low-hanging fruit guy. Go get the low-hanging fruit. Go get the easy problems out of the way. And that way you'll feel like, okay, I've started it, and you got something going on it. And then Monday you won't be so inclined to just walk away from it. So just get a little bit done each night. That's by far the best way. And I know students won't do it. I know a lot of you will wait till Thursday night or Friday afternoon or Friday evening and then try and finally do it. It's due at midnight on Friday. And the late penalties is twice as much for take-home tests. And I wrote that on the test. It's 10% a day if you're late submitting a take-home test. It's really important that you give it a try first. We're going to go over it. We're going to go over the whole thing, and probably during this week, a lot of your questions are going to be answered and worked out in the Facebook group. So that's where we can have discussions. So definitely be ahead of the game. So if you're working on it, maybe 2 problems a night, you could do the whole thing with limited misery. With that limit having to work on it at home, you could do just 2 a night, maybe 15 minutes, and then you could just roll over to Facebook and look and see what's up. What's popping on there, as they say. See what has students already worked on this problem together. Is there already an answer on there for me? Is there, has ASCII jumped in there yet? So the point is, you're not alone. As long as you have the Facebook, you have real-time help, because there's a good chance that I'll answer your question within 5 minutes if I'm on Facebook, or if I'm on my computer, I mean, I'll get a notification, and then I'll go check and see, and so there you are. Especially if you title them, if you start them QFA, if you start your Facebook post as QFA, if it is for me, that stands for question for asking, then I have it set to search that, and so it'll notify me if it finds a QFA. So that probably is the fastest way. That, and just to talk to me too, that and Canvas email, those are two. Say QFA on Facebook. I mean, text me if you have to, but it's an emergency. Otherwise, QFA on Facebook, uh, or um, or just email me. That's the third option. Email me through Canvas. All right. Talk too long. Gotta go. Let me stop this thing. I'll stop the sharing. All right, and then let me stop this thing. How do I stop this crazy thing? Okay. See you all next week. I guess Monday will be virtual with first and third hour. Right? I don't want to tell you wrong. So I recall 9:30 a.m. to 10:30 a.m. is first hour. Then 10-minute break. We'll probably stop at 10:20. I'll try and stop at 10:20 or something like that to give you. I don't know. We'll see what happens. And then third hour comes in 10:40 to 11:40, and then on Tuesday, that's when second hour comes in. Okay, so hopefully have a whole class there. That'd be cool because virtual group one, that's one thing, the way I think about it, that's the only time when everybody's together. Virtual group one and group two is during our, you know, Zooms that are virtual. So that's one good point about it. Okay, bye.